Find the location of local extrema, but here they are asking you to use second derivative test. How does second derivative test works? For local max and minimum, critical points still come from first derivative. So first derivative equal to 0 or first derivative does not exist. Please remember that. Don't make that mistakes. Critical points still come from there. But is it local max or minimum? That comes from second derivative. If second derivative is positive, then we have a local minimum. If second derivative is negative, then we have local maximum. That is your second derivative test. So let's start. We have a function. Let's find the first derivative. 5x4 minus 20x cubed. This is a polynomial, exists everywhere, so you don't need to really work on does not exist. First derivative equal to 0. So 5x4 minus 20x cubed equal to 0. I think 5 is common, x cube is common. What's left on the first part? X minus 4 times 5 is 20 equal to 0. X is either 0 or x is 4. Okay. Now we find second derivative. Why? Because we need to use second derivative test. Second derivative of the function by differentiating that is 20x cubed minus 60x squared. And we put our critical points in second derivative. Second derivative at 0 is 20 times 0 cube minus 60 0 square. That comes to be 0. Whenever second derivative comes to be 0, then we say second derivative test fails. It doesn't tell us 0 is local max or minimum. Okay. Let's find second derivative at 4. 20 times 4 minus 60 times 4 square. That you can put it in the calculator. I'm getting 320, which is positive. We said if second derivative is positive, we have local minimum. This is coming positive. So f has local minimum at x is equal to 4. That is the location of local minimum 4. But now the problem is 0 was also critical point. We cannot tell using second derivative because second derivative test fails. So when that happens for 0, we need to come back to the first derivative test. That means draw the sign chart for f prime by taking your critical points. Critical points are 0 and 4. And then pick your test points. Your test point is something before 0. Let's say -1. Something after 0. Let's say -1, +1. So put -1 in the first derivative. What is the first derivative again? This is the first derivative or this is the first derivative. When I put -1 in there, it will be positive. When I put 1 in there, it will be negative. That means f, what can we tell about f? F is increasing from before 0, decreasing after 0. So what does that mean? At 0, we have local maximum. F has local maximum at x is equal to 0. That we found using first derivative test. Local minimum at x equal to 4. That we found using second derivative test because that worked. But for 0, second derivative test failed. So we applied first derivative test.